All right, guys, well, welcome back to the shop. I'm working out on my car in front of my 2001 Beaver Patriot Thunder, and we just finished repairing and adjusting the main slide out. I didn't show you me replacing the slide out seal right here, which is just a simple bulb and wiper seal from AP Products. There's the part number, and it's a self-adhesive wiper seal right there. The only thing that you have to remember on a 3M VHB tape, besides cleaning the surface really well, is that you do want to apply adhesion promoter to the surface before you stick the seal on there. Otherwise the seal will get ripped off again. So that wasn't too complicated. But I would like to show you another upgrade I just did, and then I want to do another one with you guys. So the first one's just inside in the kitchen. We'll close off the curtain and turn off all the lights so we can see my new project is finished. I have aisle light, indirect floor lights right there. That was a fun little project. And I'd like to do another quick little project that I've been meaning to do. And hopefully it won't take 30 or 40 minutes for me to show how it works, because we're going to be right here at the dash again. I know everybody loves it when I do quick little updates and modernizations on my 2001 Beaver Patriot Thunder. Like when I did the dash radio update right there. What I want to do next is right here on the door lock. This was equipped with power door locks. Confusingly, all this does is lock the compartment doors. So when I go to unlock it, it does unlock. And it just does all the compartment doors on the outside. The confusing part is that it doesn't do the front door. But one thing at a time. I can't keep telling everybody this 2001 Beaver Patriot Thunder is the best RV ever made if I don't even have a wireless key fob on my keychain to operate my power door locks. So in my front compartment full of all sorts of future projects I want to do, I do have this system. A very generic off-the-shelf keyless entry system. I think this was less than $20 on the Amazon. I don't even know what name brand it is. The only reason I got it is because the key fobs look pretty to me. Now the installation should be pretty straightforward and simple. I'll follow the instructions on there. My RV will be different than your RV. Beaver did a little bit different. I did have to trace that out. Basically, everything is done through this door lock switch itself. There's no relays or controllers I could find, so I'm just going to pull the switch out. I'm reaching behind the dash here and pushing it out. Not too difficult. Right there. Now I say not ideal. It's just not normal how Beaver did this. So there's power coming in on the top and the bottom, and ground at the top and the bottom, and then power's going out. All this switch is doing is reversing the polarity, going in and out to a standard servo motor like this, or like this down below. This is kind of a better indication of what that rocker switch looks like. It's just a momentary switch. You can see the connections just switch polarity to the common outputs right there. So that when you apply power momentarily, it'll extend it. If you reverse polarity, it'll retract it. And it's momentary so that you're not applying power to the motor the whole time. Now most manufacturers don't wire those directly to the switch. They use relays. So that way they can use smaller wires on a smaller circuit to trip the relays right here using lower current. And then these relays would actually do the reversing of the motor there. And instead of running all the current through the relays on the controller right there, it would just be switched low current to the relays here, which would do the heavy lifting. But these motors or actuators don't actually use a lot of power. I think it's maybe 200 milliamps, maybe. And sure, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 doors or actuators. So we'll round it up to 10. So that's about 2 amps if my math is correct. Is my math correct? Because they'll be doing all this, because they'll do all 10 actuators at the exact same time. That's why I said your installation might be a little bit different than mine. Instead of tripping relays, we're going to be tripping the actuators themselves. I mean, I guess I shouldn't assume how much current the actuators use. So let me just mock this up real fast. I'll use a Wago right there on my meter. Set up for milliamps. Set up there. All right, so excuse my crudeness of my setup here. So power directly to the actuator off the battery, from the battery on this side to the meter, through the meter, back out of the meter to this lead over here. So when I hook it up, looks like it's using 1 or 2 amps. It's disappointing. Now I have to rethink my operation, because the contacts on this switch can easily handle at least 20 amps. If we have 2 amps per actuator and 10 actuators, that could be momentarily looking at 20 amps, which I'm fairly confident the little relays built into this board can't handle. So I have to make relays, which is crazy unfortunate for me, because now this job just got about 2 or 3 hours longer, and now I have to wire it up the way the factory should have wired it up 25 years ago. Now the good news for me is, because Beaver wired it like this, pretty much all the wiring I need is going to be accessed right here. I can get to the wiring underneath, and I think I just need to get access to the parking lights right over there. Luckily, I have the relays right here, the sockets for the relays, and wiring to do it all. It's not much, it's just going to be a little bit more complications. Let me first just mock everything up so I can try to explain it to you guys, so I'm not doing it behind the dash and just telling you all about it. I will explain this entire circuitry to you. Just let me test this out. We'll take it off the floor and onto a bench, but let's see. If that works. Try it on the other one. That doesn't work. Go to this lead down there. Now hopefully when I lock it, the light turns on, but when I unlock it, the light doesn't turn on. We're doing good. So if we unlock, that works. And if I unlock, it does work. If you can master this 2 relay reversing 12 volt circuit, the automotive and RV world is very, very simple. It's still kind of cool. All right, let me get this onto a bench. We'll try to discuss everything. All right, so I moved everything onto a bench top right here so we can try to make it make more sense. Now, I did not plan on doing a basic 12 volt overview for the video, but we'll try it real fast. The important thing we have to learn about first off is the standard Bosch automotive relay. It's really 2 switches built into itself, into one. It uses low current to actually move a plunger up and down and make contact between 30, 87A or 30 and 87. So basically that relay is just a normal switch that uses an electromagnet and a plunger rather than somebody's finger to move the contacts within it. There's another common switch you might see in an RV, just opens and closes those 2 contacts there. Same with this one right there, just a little rocker switch. All it does is open and close a wire, that's it. Basically you got a wire right there, and we're opening and closing the connection point and making a circuit. The only thing that's kind of strange about this is, like I said, it's like 2 switches in one. One's always connected, that's 30 and 87A. You can see the plunger is always making contact right there. The only time that plunger moves and connects 30 to 87 is when we have current going on 85 and 86. So we'll have to have ground and power to energize that coil to pull the plunger down. So at that point, 30 and 87 are in contact. As soon as you let go of the switch, where the coil gets de-energized, that contact goes back from 30 to 87A. Now these heavy-duty automotive Bosch relays, named after, okay, there you go, Bosch, can handle about 30 amps all by themselves. Whereas on this board right here, they do have relays. Even though they're saying they're rated at 20 amps, the current right here says it's less than 5 milliamps. So maybe I didn't need to go all through with this, but I'm doing it anyways. Because if 20 amps is its maximum, I think I'm pretty close to 20 amps anyways. And I don't want this to fail immediately. So these relays in there work the exact same way pretty much as these relays out here. They even have a diagram showing you how they work. You can see the coil right there. It switches between that contact or that contact, depends on if it's energized or not. Now this reversing circuit using 2 Bosch relays, I will try to at least make some sort of a rudimentary drawing over here so it makes more sense rather than this nest of wires. But on this socket right here, white and black are going to be the coil on the relay, so 85 and 86. So whenever those get power and ground, that relay will click and connect 30 to 87. So I have both those leads put together to a master ground right here that just goes to battery ground when I hook it up to battery ground. So they always have ground right there. The power, the switch power for that relay is going to go on the black wire, which I'm going to the yellow and black, and then the yellow. On the schematic right here, that's what's coming out from the controller here. Those will engage these relays. It's just replacing your finger on that switch on the dash. The key to making this work is that 30, which is going to be our common, okay, that's blue. I'm having it go out as the output. The blue is going to blue on the actuator, and this blue is going to the green on the actuator. So that's power out from the relay. Now we just have to have power into it for the relays to switch. And please try to pay attention. This is the important part. The yellow wires on these sockets correspond to 87A on the diagram. I have those wired directly to battery ground over here. So basically, this has ground on both sides of this motor actuator at all times. The only time we'll ever get power out of these relays is when we activate them, because the two red wires right here correspond with 87. So how do we switch polarity? That's the key to this. So if I just hook this to battery negative to energize my circuit, and then the red one over here to battery positive. All right, I just have my multimeter right in there. You can see we have, we're calling it 10.87, so my battery's a little bit low. Now, if I hook this lead right up here to power, we extended that, okay? But if I hit the other one up to power, we're retracting it, because when this coil gets energized, I'm not sending power to this one to be energized. This one's always going to be ground. This one becomes positive, okay? But if I send power to this coil and not that one, this one becomes energized and sends power down to the motor, while this one still stays normally closed to the ground. So we're switching polarity to this motor just by switching leads on the relays. It's nice to have this always grounded, though you could do it with always power here at the motor. The problem is, on a vehicle with a chassis ground, every single part of this metal is ground already. So if we were sending power on both of those wire leads all the time, and let's say this gets pinched in this mechanism right there, or somebody puts something in there and damages the wiring right there, we're going to short it very easily and blow the fuse. If we send ground on both those leads and the wire gets damaged and it gets shorted to ground, it doesn't matter because it's already shorted to ground. It won't work, but we haven't blown the fuse, and which is really important because we have 9 or 10 of these actuators. If one of the wiring goes bad, it won't be too bad. So for me, I do like to wire to ground as a default and just send power momentarily when you hit the switch or the remote fob. Now, I strongly doubt if I explained that well enough for everybody to understand, but this is a very common circuit that a lot of manufacturers use in both the RV and the automotive world. The only thing you have to understand is that we're using low amperage or low current to switch higher amperage or higher current, which is the whole purpose of these relays right there. Now, in the RV world, they use oversized wires all the time, so cost savings isn't as big of a deal as it is in the automotive world, but this is basically a relay too. You use low amperage or low current to switch these high current outlets, these high current posts right there. If you had to run 2-watt cable to do the relay, it gets expensive at that point. Instead of just being able to switch this entire solenoid 200 amps load with a tiny little 14 or 16 gauge wire. So putting that aside for now, don't pay attention to that stuff anymore. The only other thing that we do have to do is use this relay right there for the keyless entry control. And to do that's pretty simple. The logic of the board gets power on red and black. And then the control side of it, we're just using this diagram right here. We have basically power coming in on yellow and black. I'm sorry, power coming in on white and white and black, and then it will go out on yellow and yellow and black. So I got power hooked up right there. There's the white leads to power, and then right here is a yellow lead and the other yellow lead. And then each one of those gets hooked up to the corresponding black wire on the relay. Just like that. So now the board has power from the battery. It's already been programmed to the key fob. So let's see what unlock does. It unlocks. And the whole system works. The only thing that's going to be different is that when it comes to the original factory wiring from Beaver, I won't need to have reverse polarity be performed by the switch here. I just need to basically use this momentary switch to send power to this side of the switch or this side of the switch, mimicking what I was doing with the black wire down on the bench. And if you're asking, do I know which one is lock or unlock? I don't know that yet. I won't know until I'm at the end. But hopefully you can understand why I've been using Wago connectors for this, because I can take this all apart and put it all back together, and I haven't even used any connectors. These are still reusable. See, look at that. Already a lot less confusing without all the extra wiring, and I even got to save my Wago connectors. And if you're asking, what are those other wires on the controller that I'm not using? I'm not using all of them, other than probably the brown one to flash the marker lights when I lock or unlock it. I won't be activating a horn. I don't like that. I'm not raising a window or popping a trunk, so I don't need those wires either. And this little weird guy that's been hanging off the side, that's just the antenna. Key fob can be heard. I don't know what the range is yet, but I only got it because it was pretty. That's the only reason why I got it. It was slick, easy, and looked simple. I don't need a lot of buttons, just lock and unlock. First step up here is to disconnect all the wiring on the switch here, because I won't be using half of it. Now this is the light that lights up with the headlights or the parking lights. Look at that. Thankfully, Beaver already did label all my wires, so I know what everything is. You can actually see where they just loop these wires together and crisscross them. Looks like that's already built into this switch. Ground right there, and power on that side, just like battery power. That's all this is. These other two are actually the ones going to the actuators down below. So really the first thing for me to do is just pull the wires down here so I can access them a little bit easier. Alright, well, I know these sockets make everything look cleaner and a lot easier. I think just going straight with spade connectors on this will make wiring a lot simpler. I think. So white and red were both power. We wanted those together. And we're going to be tapping off of this, so we'll cut off the power leg from the dash. And we'll put all these together. It might look ugly, but those little wires are little wires. They don't take up a lot of space, and it's hard to make connections on them. And we'll get a yellow spade connector. Put all those together. Look how easily that fits in there. And then crimp those together. And then black is ground. It's going to go to the ground from the switch. Same thing again. I'll just be using a yellow spade connector. Just like that. And don't forget, I need to loop the ground twice for the coil. So I'll just make 2 jumpers off of those. But the wire's a lot smaller, so I can just use blue spade connectors right there. They don't have to be heat shrink. It's just what I happen to have. Now I need to do that with the red power too, to send power up to the dash switch. And I'm just going to use a bell nut or a speed nut, because again, those wires are pretty small and Wagos may not grab those very well. That seems like more than enough to get to the dash, so we'll cut it there. More blue spade connector. And we're almost ready to actually wire this relay system all together. You guys following along? Does it make sense in your head? Am I doing it wrong? You guys, I don't know. We'll find out. I mean, I get to edit this when I make a mistake. But hopefully, I haven't made a mistake. Okay, is this what you guys were picturing when I was wiring it all up? I just have to feed these up to where the dash switch is going to go. Pull those back through. I'm not going to cut these short. I'd rather have them too long, and I'll tie them up out of the way. Now as I put these last spade connectors on, I want you guys to all know I'd already checked the power to this door lock circuit. Doesn't go off of switched house power or switched chassis power. So it's power all the time, just like you'd have radio memory power. All right, I think that's pretty much everything except for I do have to run one more wire to the park brakes or park light switch, but I'll do that later after everything works. Now you don't have to take my word on it, but I did just check and make sure that this is the center contact, or this is the common, and then it's switched however you hit the switch one way or the other. I'm only going to be using half of those contacts. All right, so that way, if I do the switch one direction, we have continuity. If I do it the other way, we have continuity. So red wire in the middle, that's power, and then this would be lock or unlock. I don't know which one it is yet. I might have to change the direction depending on which one I hook up to. All right, now for those paying attention, this is the door lock and unlock that go down to the actuators, the little motors like that. Those get hooked up to pin 30, one on each one of the relays. And they are labeled on the bottom side generally. 87, 87A is the middle one, and then 30 is one below that. We're going to hook up ground to 85. It doesn't matter if it's 85 or 86, just as long that's on 85 or 86. And then we want ground also hooked up on 87A, so it's all-time ground to 30, which go down to the actuator. So now it look a little bit just like that. Are we confused yet? Now our two main power leads that are going to send power down to the actuator are going to go on 87 and not 87A. So this will be switched when the coil gets energized from the yellow wires from the switch above or the controller right here. So those are the last ones to hook up. So that's all wired up. Like I said, the rest of these wires are really not using except for brown that goes to the parking lights. I'll get this stuff all out of the way, but that's why I said it'll probably be better if we make all the connections on the relays themselves rather than having all of these with a whole bunch of connectors to another connector. This eliminated a lot of connectors. But enough of that. Let's see if it works. Door lock. I heard it lock and unlock. Let's see if door lock is lock or not. That's locked. So then door unlock would be down. Or now it's unlocked. That's very exciting. We're almost there, guys. Now all I have to do is connect the brains of the matter to that plug right there that we wired in. Okay, and let's see. Key fob. I already lost it. Okay, that's not good. There's a key fob. All right, let's see how we do. So, unlocked. Let's see. Lock. It's locked. Unlocked. I think we worked. That's a massive upgrade to my RV. I have a key fob for my power door locks. Lock. Unlock. Let's see how far away I can get, huh? All right, I'm gonna lock it. It's locked. Let's try to go in the middle of my donut over there. Try to unlock it. Oh, I even heard it work. Maybe I have to go further. Lock. And we're locked again. I don't know about you guys, but I'm really excited about this upgrade. Last thing I have to do is get the marker lights right up there. The brand new marker lights and clearance lights to activate when I lock or unlock it. That shouldn't be too difficult because to get underneath the dash right there and find the wire that I need. Let me go ahead and do that real fast, and I'll try to dress up my mess down here. It should look a lot better on such a beautiful coach, but that's why I already had it wired underneath here so I can tuck everything underneath the dash and put it all away so nobody has to look at it. I didn't even have to take the dash apart to do this because I don't like pulling this out if I don't have to. All right, so I got it hooked up underneath right there, around over here. And so now if I turn on the parking lights, look at that. And if I do the dimmer, it's not dimming, so that's the parking lights. But more importantly, it looks like it has a diode built into it right here. So if I do hook this up, there. And then I turn the parking lights back on again. Brown wire is right there, so it doesn't backfeed because of the diodes protecting it from backfeeding the parking lights into the controller. Well, let's see if that did anything. All right, let's see. We lock. Hey, even the driving lights turn on. If I unlock it, very cool. Oh, even the plate lights come on. Flashes twice when you unlock it. Well, there it was, guys. A fairly simple, if not involved, keyless entry installation for my power door locks on my Beaver. I now have a key fob. It goes on my keychain. Look like a modern RV. Very simple. Lock. Unlock. I just need to go ahead and tie this all up so it's not ugly this time. Alright, I was able to put it on the firewall way back there. Don't forget my flashlight. Alright, we'll put the cup holder away. Put that switch back in place. Try it again. Awesome. Well, the installation is done. I'm very happy with the way it works out. Why did I choose the generic sounding keyless entry system on Amazon? No other reason. No other reason. The key fob appealed to me, and I think it was like $19. We'll see how long this lasts, but it doesn't seem like it's very complicated technology that's been around for 30 years now, so I think it's going to be pretty simple and long lasting. But the reason why I did this isn't just so I can lock and unlock my compartment doors with a key fob, because that's actually not that useful. I have big plans with some parts underneath here to make my entry door a power door lock too. I'm also eyeballing a space right around here to possibly not even have to use a key fob to lock and unlock the entry door and compartment doors when I'm all done. But that was it, guys. I will put the link to that keyless entry system in the description. No big deal if you use it or not. I just know somebody's gonna ask me. But otherwise, that was a fun little project, and I'm happy it's done. One last thing on the list. Bye. To operate. All right, was anybody paying attention? Can they help me out and remind me what I was supposed to do? So when you go one way with the switch, let's see.